Harbor Charger can carry up to 1,200 passengers with no vehicles, or if she's carrying vehicles, up to 600 passengers concurrently. So it's a lot of people on a 190-foot boat. Conrad did an incredible job with the engine room on this boat. When you get into the engine room and you're looking around, there are a lot of electrical cabinets full of wires and flashing lights, and there's cables routing everywhere. The boat has something over 50,000 pounds of cabling routed through it. So in a 190-foot boat, that's a lot of cables.
This is Greg Troutwine with Maritime Reporter TV, and we're very pleased to be joined by David Turner, Project Manager, Elliott Bay Design Group, to discuss EBDG and its role in helping to bring to life one of the most exciting deliveries of the year in the U.S., and that is the new Trust for Governor's Island Harbor Charger. So, David, to start us off, can you give a brief overview of your responsibilities at EBDG and EBDG's cumulative role in the design and construction of Harbor Charger?
Yeah, so I was hired into Elliott Bay as a naval architect, and since transitioned into the role of project manager. With this project, we started with a concept design for the trust. We'd done the previous design, the Governor's One, working with Conrad Shipyard. And so the trust knew us from there, and they contracted us here. We did the concept design with them, went into contract design, and then worked with them on putting together the RFP, doing bid reviews, worked with them a little bit on the shipyard contract side, and then went into an owner's representative role in the shipyard, just overseeing their interests at Conrad. Now we're in a warranty support period that will last for the next 11 to 12 months.
Can you really kind of dig down, just kind of give, from your perspective, the highlights, the technical perspective highlights for this vessel?
Yeah, so Harbor Charger is what we call a Super K. That's not really an official designation, but Subchapter K is for small passenger vessels, carrying over 150 passengers on a daily route. And they're usually seen as limited to 600 passengers. That's because when you get over 600 passengers, they start bringing in some of the requirements of a Subchapter H vessel, things like stair towers and firefighting and whatnot. So you don't see a lot of Subchapter K vessels out there with more than 600 passengers. Harbor Charger can carry up to 1,200 passengers with no vehicles, or if she's carrying vehicles, up to 600 passengers concurrently. So it's a lot of people on a 190-foot boat. Outside of that, obviously the biggest thing is the hybrid propulsion system that she's got. It's a couple of diesel generators. They're C18s, 599 kilowatts each, and two battery rooms at I think 396 kilowatt hours each in the battery rooms. Those are Siemens batteries, and we have a Siemens Blue Drive ecosystem that's the battery management system. She's got two SRP shuttle rudder propeller thrusters, one at each end. And she can run in a diesel only mode, which is how transit from the shipyard in Louisiana up to New York City was done, or periodic runs to shipyards for extended duration could be done that way, or in a backup mode if for some reason the batteries need to be taken offline. Right now, she's on the run today, working in a hybrid mode. And exactly how that works will be determined operationally by the operators as they get accustomed to the vessel. We had a theoretical model where one generator would be running continuously at a moderate load, and the batteries would cycle up and down in a peak shaving mode. The vessel can also operate just on batteries alone. On the christening day, they turned off the generators before passengers started coming on board, and we crossed over from BMB to Swassons, and then went out around Governor's Island. We went around the west end of the island, down around the south tip, and as we were coming up the east side of the island is where one of the generators kicked back on. The battery's gotten down to a 30% charge. So she's got decent range just on batteries. And eventually the island intends to install high capacity shore charging in the Swassons end of the route. And then she'll be able to run day to day just on batteries alone.
When you look at it, when you kind of step back and say, wow, on this vessel, is there one showstopper, the equipment or capabilities that really make it unique?
You know, the redundancy in the propulsion system is a really nice feature for the island. They've essentially got 4 sources of power, any one of which can operate the vessel independently. You know, they got the 2 energy storage systems, the battery rooms, and then they've got the 2 generators. So it gives them a lot of flexibility in how they want to run the vessel. It brings with it a level of complication as well. You know, when you get into the engine room and you're looking around, there are a lot of electrical cabinets full of wires and flashing lights, and there's cables routing everywhere. The boat has something over 50,000 pounds of cabling routed through it. So in a 190-foot boat, that's a lot of cables.
How is this electrification trend inherently changing EBDG, or is it?
I wouldn't say it's inherently changing EBDG. I mean, you know, we've got a history of working on alternate propulsion systems. We've done a lot of work with LNG and things like that. We've got a hydrogen reformer tug vessel that's in late stages of design right now. So we're always looking at alternate energies. We've got a strong electrical division at the company, so we do all the electrical engineering in-house. And you know, we're engineers. We like to look at what the options are for the future. This has been a good one to go down. The first hybrid vessel that I got involved with was built back around 2006, 2007, and she was filled up with lead acid batteries. You know, the hope was that by the time they had to replace the lead acid batteries, hydrogen fuel cells would be readily available and they could put those in. The technology didn't come quite that quickly, but it has come a long way since then.
So when you compare Harbor Charger to a traditionally powered ferry, from your point of view, what are the unique design and construction challenges?
You know, so I'm involved in a few of these different projects right now. Harbor Charger is a subchapter K vessel, which means she's got a lot different manning. We're doing subchapter H vessel right now that has the Siemens Blue Drive system on it as well. It has the plus C, not the eco. And a lot of it is understanding how the crew is going to be interacting with the system. You know, in Harbor Charger, we don't have an engineer's operating station. She's largely an unmanned engine room. In a subchapter H vessel, you're going to have the engineer's operating station. And so a lot of the controls get moved down to that location. A lot of the monitoring happens inside the engine room. So it's crew access to the equipment and interaction with it. And how is it going to be maintained? How is it going to be monitored? These are different challenges. And as we get more and more gear in these machinery spaces, it does become a challenge. Conrad did an incredible job with the engine room on this boat.
Can you put in perspective the additional cost by percentage, perhaps, or however you want to position it? The additional cost to design, build, and operate Harbor Charger, and then really, what are the operational benefits that come along with that cost?
Well, for the cost, I think you should be talking to Governor's Island, see what they think about the costs as they get into it. You know, the benefits of operating a vessel like this, like you said, initially they're seeing reduced emissions, cleaner operation, getting the generators working always at their prime loading instead of, you know, having primary engines that are lugging down around 10-20% loading part of the time. So emissions should be a good improvement. And as they get the infrastructure in place to do electrical operations, there's potentially a lot of savings operation and just not purchasing fuel. That can be a complicated question. You get demand charges on electricity, and so it does require advanced planning and forethought to understand what the actual costs are going to be. But certainly the fuel savings will be a great thing for the island. And it really aligns well with their position. They're very concerned with global sea level rise there. It's something that's studied on the island. It's important to them. And so this kind of goes hand in hand with the philosophy of the development that's happening then.